Testing 1, 2, 3. Welcome year 9 and 10 students. We are looking at the atomic model today. Let's get cracking. Right, your driving question for today is, how was the nuclear model of the atom developed? Okay, so this is kind of the history of coming up with the model for the atom. So our keywords today are model, alpha particles, vacuum, positively charged spheres, and negatively charged electrons. Now, we have come across charge before, and hopefully you will have seen the ideas of a model before, which is effectively the way that scientists use to explain things. Okay, alpha particles are small positively charged particles, which are the nucleus of a helium atom, actually. So two positive protons and two neutrons. A vacuum is like outer space. It means all of the air has been removed. Right. Your starter for today, beside this, is can you fill in the gaps? What I'd like you to do is pause the video and think for a couple of minutes what is going to go behind those question marks. Pause the video now, and then we'll go through the answer in just a minute. Okay, so the first one is the electron. Electrons are found around the outside. You've got protons and neutrons in the middle. It doesn't matter which way around you've got these because there are 6 of each and 6 electrons. One's hiding behind there. Right, so inside the atom, you've got protons, neutrons, and electrons. What are their masses? That means relatively how much stuff is in them, I suppose. So protons and neutrons have a relative mass of 1 each. So that is where the mass is kept. And an electron has such a small mass that it's negligible, we hardly count it at all. And the charges of these subatomic particles are protons have a positive charge, neutrons are neutral, not negative, neutral, they have no charge, and electrons have a negative charge, the same charge as a proton except negative. Okay, so this is a quick recap of the atomic model that we use at the GCSE level. Right, so you may have seen these two models before. This is the model for the geocentric theory of the universe compared to the heliocentric theory of the universe. Before Galileo and his science, people thought that the Earth was in the center of the universe with the sun and the moon orbiting around the outside. But through scientific investigation, through new discoveries, we found that actually we'd better change that model and have the sun in the center of the solar system and have the Earth and the moon and the various other planets to orbit around the outside there. So there's one example of how a model in science can help explain the universe, but then changes over time because of new evidence and investigation. And actually, the way that the nucleus and the atom, that the model of the atom changed over time, is very similar in that respect. Okay, so thousands and thousands of years ago, you had the ancient Greeks, and they were kind of the first people to come up with the idea of the atom. The idea that if you got a material and you chopped it up in half and in half again and in half again and in half again, you would eventually end up with something that you can't chop in half anymore, the smallest divisible piece of an object, and they called this the atom. Okay, now all the way up to John Dalton carried on this idea in 1803 that there were these particles, these balls that make everything up. Okay, and it is through the work of scientists Thomson, Rutherford, Bohr, and then more after that, you saw the atomic model change throughout history, and this is what we're going to be looking at today. So in 1897, a scientist called Thomson effectively discovered electrons. Now, he did some cathode ray experiments where effectively shot electrons as a cathode ray, and then found that if you passed a magnetic field or an electric field through it, these particles would be deflected. So Thomson found through his cathode ray investigation that electrons were negatively charged, existed, and must be part of the atom. So his model, so changing from the fact that there were these tiny atoms that are these balls, he decided that actually these were spheres of positive charge that had the negative charges, those electrons, dotted throughout it. This resembled a plum pudding, which I suppose is something similar to a Christmas cake or maybe a hot cross bun. You could think of it like that. And although this is not the one that we use today, it certainly was a step forward from the original atomic model, as you've got the electrons are counted now. Okay, so this is the plum pudding model. Right, can you please pause the video, have a think which one of these answers best explains what the plum pudding model is. Pause the video now and we'll go through the answers in just a second. Right, the answer is A. The plum pudding model is a positively charged sphere with the negatively charged electrons randomly arranged around the outside. All of the other ones are wrong for some reason. Right, the next investigation that happened after this was from scientists Rutherford and Geiger and Marsden. So Rutherford, Geiger and Marsden were the scientists that kind of took the model forward, and they did that using the gold foil experiment. Okay, so Rutherford set his assistants Geiger and Marsden to investigate if any radiation was reflected back by gold foil. Effectively, what he did was he got a piece of foil, very similar to aluminium foil, like you get in the kitchen, except it was made of gold. What they did was they shot alpha particles, which is a small helium nucleus, the type of radiation, and they shot it out of a radioactive source and saw what happened when it interacted with this gold foil to try to get a better understanding of the gold atoms that it was being shot through. So, thin sheet of gold foil was placed in front of an opening to a lead box containing alpha radiation. This apparatus had a movable radiation detector, that's this bit, which was in a dark evacuated chamber. Now, the reason it was in an evacuated chamber, or you could say a vacuum, was so that the air particles, which are obviously made of matter, aren't getting in the way. So the only things that were there were the gold foil, the alpha particles that were being shot out, and the detector, which would detect where the radiation appeared. So the investigation went like this. They moved the detector to different positions around and saw how the alpha particles basically interacted with the gold foil. So in position 1, which is where they expected most of the particles to be, it's directly on the other side of the foil. And they saw that in 10 seconds, loads and loads and loads and loads of alpha particles went through. So that just showed that they went in a straight line. Position 2, what happens? Some alpha particles must be deflected. So you can imagine the path the particles went through like this and have bounced and changed direction and managed to get to position 2. But what was really surprising was what happened when they put the radiation detector behind the foil. Let's see what happens then. Look at that. So occasionally, now very occasionally, the particles of alpha radiation in fact bounced back off the gold foil, which was not at all what they were expecting to see. Next slide. Right. So because we've got now some new evidence, Rutherford decided to change the atomic model. So in Rutherford's nuclear model, the atom is mostly empty space with a tiny positive nucleus orbited by electrons. Okay, why did he come up with this idea? Well, most of the alpha particles pass through the gold foil. In Rutherford's model, most of the atom is empty space, so these particles pass right through the spaces between the gold nuclei. Just like that. So the alpha particles go right the way through, because most of the atom is empty. A few of the particles did not pass through the gold foil, but were slightly deflected or even bounced back. How did Rutherford's model of the atom explain these results? Well, an alpha particle has a positive charge, so when one came near the positive nucleus of a gold atom, it's repelled because the like charges of the nucleus and the alpha particle repel each other. So this deflected the alpha particle off at an angle, which explains those ones changing direction. When a positively charged alpha particle heads directly towards the positive gold nucleus, it's also repelled. In this case, the alpha particle bounced back off the foil, travelled back towards the source. And here's a quote from Rutherford himself. "It was quite the most incredible event that ever happened to me in my life. It was as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came right back and hit you." So, obviously not what he was expecting. Right, what I'd like you to do now is, just like in class, the think, pair, share activity. I would like you to have a think about this question and go and find a partner and explain to them the answer, please. So maybe that could be a parent or your pet dog or cat or frog in the pond. It could be your neighbour over the garden. If you can explain the answer, it means that you can understand it. So what I'd like you to do now is pause the video and go tell someone the answer to this. What conclusions did Rutherford get from the gold foil experiment? Go. Okay, hopefully you've had a quick go at that. Let's have a look at the answers. Well, the alpha particles went right through, so the atom is mostly empty. This is the first conclusion that Rutherford could make. The atom is mostly empty space because those alpha particles went right the way through. Second conclusion, sometimes the particles were reflected so that the positive charge is concentrated. This is where the idea of the nucleus came from. So nucleus would be fine as well. The positive charge is all in one place. And because only occasionally would the particle bounce back, so only a small amount of the atom is positive. So the atom is mostly empty, the positive charge is concentrated, and it's concentrated in the middle. This is where Rutherford's model of the atom, which looks a lot more similar to what we've seen before, with a nucleus in the middle and the electrons around the outside. So again, most particles went through, but most of the atom is empty. The fact that they were deflected and occasionally went back shows that the nucleus is small compared to the size of the atom and contains most of the mass and all of the positive charge. Right, and it would look something similar to this. Notice that there are no there are no shells, the electrons, they are just around the outside. But the difference between the plum pudding and this one is that all of the positive charge, all the what will be discovered as protons, were in the middle there. Okay, this is Bohr. This is in 1913. The scientist Bohr did some work on the arrangement of electrons, and through some more experiments found that they were arranged in these electron shells around the outside. So he did similar experiments to the when you burn the chemicals and they've got similar colors. That's because of the changing of electron shells. Okay, further investigation came in 1932 from someone called James Chadwick, who discovered the neutron. So up to this point, they realized that all of the mass is most of the mass is found in the nucleus in the middle, and there must be more particles than just that positive protons. They thought there must be neutrons, but it wasn't until James Chadwick actually discovered them that and did some investigations to find that the neutrons appeared. So I suppose the order in which that they were found is electrons were discovered first, that's followed by the plum pudding model, then the idea of through the gold foil experiment, there must be a nucleus, which is where the positivity is kept, and then there must be neutrons as well to make up the rest of the mass. Okay, again, I would like you to have a read of the questions, think about which answer is actually wrong, and all of the others will be facts. Pause the video and decide which statement is false. Okay, what's the answer then? B is false. So A, Rutherford fired alpha particles at gold foil, absolutely true. Most alpha particles went through the gold foil, but which shows that most of the space is empty. C, some alpha particles were strongly deflected, absolutely true. And the fact that the deflected alpha particles show nucleus to be positive and contain almost none of the mass, not true. It contains most of the mass. So that one is the false one. Right, just like in, we'll forget about the worksheet bit, that's not right. But just like in class, I'd like you to have a go at the writing phase. So on the top of your sheet, I would like you to put, on the top of your paper, I'd like you to write the driving question, get that underlined and use full stops and capital letters. Make sure that you've got a question mark at the end. This way we can keep our work organized, so it will make sense later on when you go back and look at your notes. So start with the orange section. This will be recalling key facts and using the keywords correctly. The green section is being able to explain key ideas in science. In this case, it's what the plum pudding model is. The U section is to be able to apply your explanation to the new context. In this case, what is the evidence that showed that the plum pudding model became the nuclear model? And finally, the blue section is to compare the plum pudding model with the nuclear model, giving similarities and differences. Down the bottom are some key words. Please can you use these in your answers. Remember to use full sentences. And can you pause the video now and have a go at that before we go through the answers? Right. Now is the time in the lesson where we would use a green pen. If you have got any other coloured pen at all, now is the time that you can give your answer ticks if you are correct, or if you're missing any of the scientific detail, now's the time that you can add that in. Right. In what order did the event happen? Well, it goes C, A, B. First, the electrons were discovered by Thomson. Then Rutherford discovered the nucleus and the proton using his gold foil experiments. And then finally, Chadwick discovers the neutron. So electron, nucleus, neutron. Right, the next one says draw the plum pudding model showing the negative electrons and the large positive sphere and explain the model. Where one way to explain this is that you've got a large positively charged sphere with negatively charged electrons dotted around on the outside. On the next slide, we'll show you a diagram of that. The yellow section says describe the evidence to show how the plum pudding model became the nuclear model. Well, in summary, alpha particles were fired through gold foil. Most of them went through, which showed that the atom was made of empty space. Some of them were strongly deflected, which shows that the nucleus is positively charged and has almost all of the mass. So those are the conclusions from the gold foil experiment. And then finally, compare the plum pudding model to the nuclear model and give two similarities and two differences. Well, here, just like hopefully you've got for the explain task, you've got the plum pudding model. So the positive charge, the whole thing's positive, and you've got these negatively charged electrons throughout it. Compared to the nuclear model, where you've got the nucleus, which is the positive protons and the neutrons in the middle, and you've got the electrons around the outside. So the plum pudding model has a single ball of positive charge, and the nuclear model has a positive charge in the center. The plum pudding model has electrons in random positions, and nuclear model has electrons in fixed positions. The plum pudding model has no nucleus, and the nuclear model has a nucleus, and the plum pudding model has no neutrons, and the nuclear model has got neutrons in the nucleus. Okay, so those are some differences. Right. Like every single lesson, today I would like you to write your today I have achieved sentence. So make sure that you remember to write what the skill is that you have been able to achieve for today. So for instance, if you achieved the describe section, you could write a sentence saying, today I have achieved describe because I can recall the order in which the 3 subatomic particles were discovered. If you achieved explain, then you could say, today I've achieved explain because I can explain the meaning of plum pudding model. Today I've achieved use because I can explain why Rutherford changed the plum pudding model. Or today I achieved combine because I can compare the plum pudding model to the nuclear model, giving 2 similarities and 2 differences. Okay, so please remember to put this at the end of your work to show that you are aware of what level you're working at for this lesson. So again, today we've looked at the driving question, how was the nuclear model of atoms developed? And we use the keywords here, especially model and looking at alpha particles. Okay, so thank you very much, Year 9 and Year 10. Please check your Show My Homework for some quiz questions, which will help us see what you can remember. Right, thank you very much. See you next time.